So welcome to the project demonstration of UPS battery monitoring system with supply changeover by using electromagnetic relays. So here we are going to charge the batteries. So this is a battery pack which is used to provide the power supply to the AC load through the inverter and DC load. So the selection between the two battery packs will be done with the help of electromagnetic relay. This relay will select the which battery should be connected to the loads directly. So means whenever the battery pack 1 is sufficient voltage, then the battery pack 2, then battery pack 1 defaultly connected. If the battery pack 1 voltage is less than the battery pack 2 voltage, then the relay will switching from the battery 1 to battery pack 2, so that the battery pack 2 will provide the power supply to the inverter and DC load. So this is the switching between the battery packs to the inverter. And the next is charging switching is, so we are connecting the solar panel as a source and a transformer as a source to these battery packs to recharge them, and that to be done with the help of microcontroller based on the availability voltage. So if the available voltage is more than sufficient to charge up batteries from the solar panel, then the supply voltage will be connected from the solar panel to the batteries through this second relay. So the solar voltage will be measured by this voltage sensor, and also battery voltage will be measured by this voltage sensors. So here you can see the voltage sensor consists of two resistors, that is 10 kilo ohm and 1 kilo ohm. They are acting as a potential divider, as the microcontroller measure the voltage maximum of 5 volts because of the operating voltage is 5 volts. So but we are getting voltage from the solar panel and the batteries are the 12 volts. So for that purpose we need to divide the voltage in 10:1 ratio. So if the microcontroller gets 1.2 volts after this voltage sensor, so it will multiply it by the controller in 10 times. Why? Because we are using the 10 kilo ohm and 1 kilo ohm as a potential divider with a ratio of 10:1. So whenever the input voltage is 12, the output from this voltage sensor is 1.2 only. So like that we can measure up to 55 volts using this voltage sensors. So in our project we are using 12 volt 5 watt solar panel and 12 volt 2 amp battery packs for the inverting circuits, and the same thing from this transformer. So here we are providing the 230 volts input to this transformer, which will step down the 230 volts AC to 12 volts of AC, but we need to provide the DC power supply. For that purpose we are making use of this regulated power supply board. It has the rectification section, filtration section and regulation. Rectification to convert the AC to DC, filtration to remove the pulsating DC to the pure DC voltage, means to convert the pulsating DC to pure DC, that are 12 volts. So but our operating voltage of a microcontroller is 5 volts. For that purpose we are making use of 7805 voltage regulator, which will take 12 volts DC and provide as a 5 volts DC output. So here this 12 volts DC is the operating voltage to the batteries, means charging voltage. So parallelly we are distributing that through the relays to this battery pack. So coming to this charging circuit, so we can see that we have connected the parallelly to the voltage sensor to measure the voltage and to this charging circuit. On this one we can see there is no directly there is a bridge rectifier here. So why? Because we are providing the DC source, but there is no need of this bridge rectifier. So here we placed, purpose is like to correct the polarity, means if we connect this solar panel in reverse polarity, in reverse direction, then the plus will be given to the minus of the battery pack and minus will be given to the plus of the battery pack. So for that purpose we need to rectify them. So for that purpose only we are making use of this bridge rectifier, which will act as a polarity corrector. Right. So for that purpose only we are using this 4 diodes bridge rectifier circuit as a polarity corrector. So now, though we know that bridge rectifier will convert the AC to DC, we are providing DC only. But if we change the polarity, plus plus minus minus, that will be rectified and will provide us the output of directly plus to plus and minus to minus. The output is directed through the relay to the battery pack. So this is the main input source from the transformer and solar panel. And coming to this battery changeover, these voltages will be measured by the microcontroller. So we have interfaced the connections: solar voltage sensor, battery pack 1 voltage sensor, battery pack 2 voltage sensor, respectively A0, A1, A2 pins to the PIC16F73 microcontroller. So based on the availability of voltage of sources, we are controlling the relay which is connected at C6, and based on the availability from the battery voltages, we are switching the battery power supply to the inverter to the relay which was connected at C7, and the so-called status will be displayed on the LCD screen connected at pin number B2 to B7. So here they are the connections mainly. And coming to the inverting circuits, so it has the RLC inverter. So R resistor, L inductor, and C capacitor. As you know that RLC oscillator, which will provide us the 50 hertz of clock frequency. So oscillator purpose is it will generate the signal without giving any input signal. So the 50 hertz pulses is input to this gate of this MOSFETs. So that will be converted into 12 volts AC with 1 amp, and that will be step up to the 230 volts AC, and that is input to this load directly. So this is just on off switch to on the power supply to the loads whenever we want. So let us see the demonstration on the power supply to the transformer. So as you can see on the LCD, so as of now the B2 voltage is more right now, right? So whenever the B2 voltage is greater than the B1, then B2 will be connected. So you can see the switching in the relays also. It's continuous process. So when the solar voltage is above 8 volts, then only this another relay will get switched off, so that when it is off state, the power supply will be connected from the solar panel to the battery packs for charging purpose. So we can see that the solar voltage, and we can see there is an off indication of the solar panel was not connected to the charging of the batteries. So without any interrupting to the loads, we are switching the power supply, means we are switching the batteries, we are changeovering done.